Hello everyone, I am Akshaya from Department of Geology, A.D.M.COLLEGE for Women. So today I am going to discuss about the Aeolian processes and landforms. So the main objective of this video is to give a brief knowledge about the geological action of wind. Let's get into the topic, geological action of wind. This is my content, the Aeolian processes. There are processes like erosion, erosional landforms, transportation and deposition and the landforms. First, we'll see about the Aeolian processes. Aeolian, the word Aeolian is derived from Greek word which means the god of wind. Atmosphere is composed mainly of gases, mixture of gases that are collectively known as air. That air in motion is called wind. Wind is one of the major agents that changes the surface of the earth. The movement of wind is caused by the uneven heating of the earth by the sun and the earth's own rotation and the earth's inclination on their axis. During such a movement, wind may create temporary or permanent changes on the earth land surface, and wind acts as the agent of erosion, as a carrier of transporting the eroded material and finally deposit that transported material. So the wind action itself depends on the following conditions. The first one is the volume of active wind. Then second one is velocity of the active wind. Third one is the size of the particle in which wind carries. Fourth one is the nature of the surface over which the wind flows, and finally the amount of time it takes to carry the sediments. Then the wind action. The geological action of wind manifests itself in three forms: the erosion, then transportation and finally deposition. The erosive action. The erosive action itself in three forms. First one is the depletion, second one is the abrasion or corrosion, and third one is attrition. First, the depletion. The word depletion is a Latin word and it means to blow away. This is the process of removal of particles of sand and dust by strong wind is called deflation. Deflation leads to the formation of depression on the land surface. So the picture in the right side shows the deflation action. The first picture shows how the wind carries the loose sand and dust particles, and second one is only the coarser sediments are left behind, and third one is the coarser sediments are joined together and look like a pavement, so it is called as desert pavements. Next, we will see the features formed due to the deflation action. First one is the blowouts. Blowouts is a sandy depression in a sand dune ecosystem caused by the deflation removal of sediments by the wind. And the blowout develops in the areas where non-indurated materials. Non-indurated material means unconsolidated material which lies beneath the land surface. And the picture shows the blowout example, Quattara depression in northwestern Egypt. Second one is oasis. Oasis is also a depression which is caused by the deflation action, which is formed by the removal of sand from a particular location to such an extent that a big depression is created. Sometimes this depression may intersect the water table which lies below the zone of aeration and get partially filled up with the water. It is called oasis. Oasis is just a depression filled with water which is situated in the desert region. Next one is the hamada. Hamada is a bare rock surface in a desert which has been exposed due to the blowing out sand over it. The larger particles are only left behind on the earth surface which is protected from further erosion. Next, the desert pavements. Desert pavement is also called lag deposit, as I already told in the deflation. This is the process of removal of sand-sized particles by the action of deflation. In this, there is a sorting of material according to their size with the coarser material only left behind, called the lag deposit. This desert pavement or lag deposit is also called Rik in Western Sahara, Sir in Eastern Sahara, Gibber in Australia and Soy in Central Asia. On the right side, you can see the fine-grained particles are blown away, which is the sand and silt particles, and the wind only leaves the pebbles and boulders, that is the large sized particles are left behind and they are joined together to form a desert pavement. Next, the abrasive action. The abrasive action is also called corrosion, is a process by which wearing down of surfaces by the grinding action, rubbing action and sandblasting of wind-borne particles. In this process involving scraping, rubbing, grinding, grooving and polishing of the rock surface. And the abrasive action mainly depends on the following four factors. First one is the strength of wind. Second one is the hardness of blowing sand grains. And third one is the persistence of wind. And finally the resistance of rock being abraded. Next, features formed due to the abrasive action. First one is the yaw-down. Yaw-down is an elongated and low-lying ridges formed by the wind abrasive action. In this yaw-down, elongated in the direction of prevailing wind and are nearly always curved from the relatively weak material. Second one is ventifax. Ventifax is formed by the abrasive action which exhibit one or more polished or faceted surface. They are relatively rare because strong winds, abundance of sand, absence of vegetation are the following factors which cause the ventifax. If the ventifax has only one polished surface, it is called Aeolian. If it has two polished surfaces, then it is called zooconus. If it has three polished faces, then it is called dry contours. Next, we will see the picture which shows how the ventifax formed. First one is the original round shaped pebble. Then second one is how the wind abrasive action erode the rock surface which cause the polished face. Then pebble rotation take place due to the eddy action of the wind. Next, we will see about the next feature, natural arc. Natural arc is typically formed by the combination of the both action of wind and water. These narrow ridges are formed and the softer substrate is weathered first, forming a bridge or arc-like overhead. This is the example of arcs in National Park of Utah, which is in USA. Next, the mushroom table. Mushroom table are also called pedestal rock. It is a residual masses of weak rock capped with the harder rock resembling an mushroom shape is called mushroom or pedestal rock. It is formed due to the abrasive action of wind. Long slender stem is called pedestal and the top overhang is called mushroom. Next, the X. X are also called sand seas or very vast sand sheets in the desert region. They covers about 1/4 or 1/3 of the area of the true desert region. In these, the sandy deserts overlay the poorly consolidated sandy bedrocks. Next, desert varnishes. Desert varnishes is a dark coating on the rocks found in arid region, which means desert region, composed of fine-grained clay minerals containing black manganese oxide and red iron oxide. Desert varnishes form only on physically stable resistant rock surface that are no longer subject to frequent precipitation, fracturing or sand blasting. Then finally, third process of wind erosion is attrition. Attrition means sand grains lifted by the wind from different places or carried away to the considerable distance. Then these sand grains are wear and tear of load sediments suffered mutual collisions with one another. Such collision brings about a grinding of the particle and reduction of the size of the particle. So the attrition leads to a feature called millet seed sand. Next, the millet seed sand is a rock material carried by wind in arid areas, hit and rub against other desert rocks on the wind path and also collided with each other. They break and reduce in size. They form rounded sand grains called millet seed sand grains and fine dust. Next, we will see the transportation action of the Aeolian. So the transportation action of the wind mainly manifests itself in three processes. First one is suspension, second one is saltation, and third one is traction. Traction is also called rolling or creep. First, suspension. Suspension is nothing but a sediment such as fine sized particles like silt, clay and dust sized particle are lifted high into the atmosphere and are carried to the greater distance before they settle into the ground surface. And second one is saltation. Saltation is that transported through a series of bounces generally up to 2 meter height. Then third one is rolling or traction. Traction is the movement of particle along the ground. This coarser fragments like boulders and pebbles are carried in this way. This is a picture which shows the suspension, saltation and traction action. First one is the suspension. In the suspension action, the wind carries the fine sized clay and dust particle. Then saltation. In the saltation process, the medium sized particles like pebbles and cobbles are bounced on the ground surface. Then traction, the boulder sized particles are rolling on the ground. Next, we will see the deposition action of the wind. Deposition action of the wind includes the following conditions. First one is reduction in wind velocity. Second one is obstruction to the movement of wind, and third one is moisture content increased and precipitation increased. These are all the features of wind deposition. First one is wind or sand ripples. Sand ripples are small sand waves created with a wavelength of about 1 meter, and these are common on the windward slopes of the sand dunes. Next one is the loess. Loess is an important wind depositional feature. Loess formed by the accumulation of wind-blown silt and clay sized particle typically in the size of 0.01 to 0.05 mm in diameter, and loess is a unconsolidated, unstratified and porous accumulation of particles. Loess is usually buff colored, non-indurated, calcareous and permeable surface. This is the lowest landscape in China. Next, we will see the sand dunes. Sand dunes is an important depositional feature usually seen in the desert region. Sand dunes are mounds or piles of sand deposited with a crust with two slopes on either side of the middle crust. The leeward side has a steeper slope and the windward side is more gradual. In these, there are some conditions for the development of sand dunes. First one is the abundant supply of loose sediment, that is sand. Second one is the sufficient energy to move the sediments from one place to another, that is the velocity of the wind. Third one is obstacle around which the sand accumulates, that includes the cliffs, the amount of vegetative covers, and finally the dry or arid climate. These are all the conditions for the development of sand dunes. There are 8 types of sand dunes in which I am going to describe in this video. The first one is the barchan. Barchan is an important type of sand dune. It is crescentic in shape whose long axis is transverse, that is perpendicular to the wind action, and the limited supply of sand and nearly a constant wind is the main conditions for the development of barchan, and wind should be unidirectional. Second one is transverse dune. Transverse dune is a long, wavy and linear ridge that form perpendicular to the wind direction, formed when sand supply is abundant and there is no vegetation. In this transverse dune, the wind should be constant, moderate and unidirectional. Next one is the parabolic dune. Parabolic dune is also like a barchan. It is also crescentic in shape whose long axis is transverse to the dominant wind direction, that is perpendicular to the wind direction, in which it is convex in leeward side and concave in windward side. But in barchan, it is convex in windward side and concave in leeward side. Parabolic dune form when there is abundant supply of sand and there is no vegetation. Next one is the longitudinal dune. It is also called safe. Longitudinal dune is named after the Arabic word swat because it look like a swat and long and linear dune lying parallel to the prevailing wind direction. Longitudinal dune generally forms in area where sand is limited and the wind is constant and strong. Fifth one is the star dune. Star dune is a pyramid shaped 3 or more arms radiating from a peaked center and they develop where wind direction is variable, that is multi-directional wind. Star dune for its formation requires wind flowing from several different directions. Then sixth one is the dome. Dome is a special type of sand dune mound of sand that is circular or elliptical in shape and it has no slip faces. Seventh one is the reversing dune. Reversing dunes are intermediate between the star dune and the transverse dune. In these, the ridge is asymmetrical and has 2 slip faces. And final one is the coastal dune. Coastal dunes are mostly formed in the coastal regions. It forms when there is a large supply of beach sand and strong wind blowing from sea to the shore. Beach area must be wide is the conditions for the development of coastal dune. Dissimilar from this desert dune in their form and shape and in the fact they do not migrate. Then significance of the sand dunes. Sand dunes have some specific significance. It helps in the study of paleo environment and paleoclimatic study. So sand dunes are used to study about the ancient life forms and ancient climatic period. Then second one is sand dune represent the direction of wind flow. And third one is the global climatic changes can also be interpreted. So by using this sand dune we can assume the global climatic changes and the direction of wind. Finally the conclusion. So the wind may erode, may transport and deposit material and are effective agents in region with sparse vegetation, that is devoid of vegetation. The deflative action and the abrasion action are the 2 methods by which wind carries out its erosional activities on the Earth's surface. Mushroom table, pedestal rock, yaw dams, ventifacts, encounters are important erosional features. Wind transportation takes place through suspension, saltation and traction. Dunes, loess and sand dribbles are the depositional features of the wind. Sand dunes form in environment that favor the deposition of the sand. Examples of sand dunes are bar chance, transverse dunes, parabolic dune, longitudinal dune and coastal dune. So thank you for watching our video.